In today's lecture, we will show how you can create this graph in the Etap. Before starting this lecture, I want to tell you that on this channel, you can learn various electrical design softwares like Etap, Silent Power Factory, PV System, Dialux CO, and Autodesk. In addition to these softwares, you can learn various electrical technical details related to the electrical design on this channel. In today's lecture, we will show how you can create this graph on Etap. This is our Etap window. First of all, we will make a simple system, not more complex. I My aim is to only to show you how you can create this graph. So we can take a grid first of all, and we will enable the auto builder and select the grid. Then we will take the bus, and let's take only this thing, not more than this. Okay. Okay, double click on the grid, go to the short circuit, and place that x by r ratio will be 14.14, and the short circuit current will be 25 kilo amperes, and rating will be 132 is okay, and click OK. Now perform the short circuit analysis, and click on the duty and SC, name the output file. Okay, here is the error. The error is that the system has no energized branches such as cables or impedances. No bus is faulted. Number of energized buses less than 8. Okay, I will clear this all these errors. First of all, number of energized buses is less than 2. Okay, that in a Etap there should be 2 energized buses. Minimum requirement for a Etap for any model is there should be 2 minimum energized buses. Now how can I clear this error? I can go to this edit, and I will take the transformer, place it here, and join it with this, and then take another bus. Okay, double click on the transformer. You can put any rating on the transformer. Here I am only interested in you to show you how you can create the graph. I will enter any 20 MVA, 3132 by 32. Okay, no problem. Now we have two energized buses. One is this bus, and bus 1 and bus 2. Okay, now right click on this bus, then go for short circuit, and right click on this bus and tick the fault. Now we have cleared 2 errors. One was the you have only one energized bus, and another is no bus is faulted. Now we will see what will be our results. Transformer one, now when the positive sequence impedance is 0 and the transformer positive sequence impedance x by r ratio is 0. Okay, when you perform the short circuit analysis, you have to enter the impedance value. We will take the typical impedance. Okay, now we will see what will happen. Okay, now in this lecture you have studied 2-3 things. One, how you can clear the errors. There was first 3 errors, then 2 errors. First two errors was only one energized bus was there, and second was no bus was faulted. I have cleared these two. Then third, second time when we will run the short circuit analysis, then percentage impedance error was given related to the transformer, and I have also cleared that thing. Now this value, that is 25 kilo amperes. This is the short circuit current which we have entered here. See, this is the symmetrical value of the short circuit current. Okay, nothing where I am not discussing here the short circuit, and I have only to show you that the graph. The short circuit current has two components. When a short circuit occurs in our electrical system, there has two components. One is the AC component and another is the DC component. The DC component decays after some time, then only remains the AC component. The AC component is symmetrical, that is the symmetrical component of the AC, that is symmetrical value. And DC, when the DC is present at that time, the short circuit is asymmetrical, it is not a symmetrical. And initially the short circuit value is very high due to presence of the DC component. So now how we can find this value? You can go here display, and in the display there are initial symmetrical and three phase. Now we will select the peak and click OK. Now you can see now the peak value, that's initial peak value, is 64.087. Okay, now I will show you now how you can create the graph. In the graph, to create this graph, you have to click on this. This is the 61369 is the transient short circuit analysis run, transient short circuit analysis, and then click the graph. This window, that is the short circuit plots. Okay, now actually I have plot. Click no. Bus 1 is faulted. Okay, we will say one phase. There are three phases. We will say into one phase, I phase. That we will see the total short circuit current I. We will see also the symmetrical short circuit current, that is IAC. The symmetrical value, that is 25 kiloamperes, and we will see also the DC component. Okay, and we will combine all these plots in a one plot. We can see, if we do not take the combined plots, then it will show separate. It will show total current separate. I will show you later on. First off, we will combine all the plots. Okay, first I will show you in separate and then plot. You can see this is total fault current, and this is the AC component which is symmetrical, constant remains constant 25 kiloamperes, and this is a DC which decays after some time. Now we will combine these plots in a one plot, that it shows them in a better way. Okay, we will close this plots and it can be zoomed. Now see. Okay, now the initially this current is the total current that is in blue, it is asymmetrical. You can see that this portion, this portion is not equal to this portion, that is asymmetrical. And you can see the initial DC component, that is red line, which starts constantly going decay after almost I can take a hairline almost 0.1 seconds, that is almost 100 milliseconds, that is 3 after 5 seconds the DC component becomes completely vanish, and our AC component is going to be symmetrical. Okay, now you have seen this graph. Okay,